So confirm that you're able to see.
Yes, we're able to see.
All
Yes.
right. Thank you. Okay. So these are the points that I gave to you guys. So for the first point, le bien parfaitement divisible. Yeah, so what were you guys able to find on this? Anyone can start. You guys know I don't like pointing, so who wants to go first?
Alright, I'll go first.
Alright, Alex. Go ahead.
The first one was le bien parfaitement divisible. What I found out was since I couldn't search in French, so I had to translate that in English. Perfect divisible goods. Then what I found out was divisible means that the item used as money can be easily divided into small investments, small increments, so that it can match commodity values more precisely. So perfect divisible goods are goods that can be divided into smaller parts or portions and retain value. That's for the first one.
Okay, thank you. That is exact. I don't mind that you had to translate, that's fine. I remember I recommended that you do so in French, but for now it's not so important as long as you found what you were looking for. So yeah, thank you, Alex. Anyone else? Still on the same, of course. Did anyone else find anything that was slightly different, or were all of your answers along the same lines?
I feel like maybe just the same. I found out to say le bien perfectement divisible. Yeah, divisible. These are goods that can be divided into smaller units in order to increase or enhance their value. Just some kind of saying.
Okay, cool. That's good then. So that means the answer is correct, by the way. So that means we can go on to the next one, which is pretty much the direct opposite. So Alex and Xavier have spoken. I'd like to hear a different voice today. Can someone else come forward for that one? Anyone?
Can I try?
Yes, Sulanji, go ahead.
For imperfect divisible goods, I think these are goods that can't be shared into small units or like sold into smaller units to different customers to bring this a higher value. So let's say a TV, like you can't sell one TV among two customers. So a TV is an example. That's what I found out.
Okay, that's perfect. Yeah, that's the general idea behind it. Did anyone else find anything on the same, or were all of your answers similar? Everyone found the same?
Yes.
Okay. I'm guessing people are having network issues because the number is greatly reducing. I hope they'll be able to rejoin. Okay, so in that case, we can move forward to this one. I'll send you the answers to these. They're the ones I have here. And this is when you're looking at these things in microeconomics specifically. So you will see a number of the terms we've already looked at, like marginal utility, total utility, and so I'll send these to you. But then the last one is different. It's under a different topic entirely and might be more involving. So I'd like to hear what you found under that last point. At this point, anyone can go forward. Even if you've spoken before, you can answer. Though I would prefer someone who hasn't spoken yet. Guys, Malipo, are we together?
All right. Individual.
You can go ahead, Alex.
All right. The individual demand refers to the demand for a good or a service by an individual. It is an interaction of an individual's desire with quantities of goods and services that he or she was able to afford.
Yes,
That's
sir.
it.
In other terms, we can say demand and video them is just a function of the price of the end product, another price of other goods as well in relation to the customer's income or budget.
Okay. Yeah, that's generally it. Those are the basic ideas behind that issue. I asked you to research on this one in particular because this will be the last section we look at. Once we're done with what we're doing today and probably in the next lesson, that will be the next topic we do. So I need you to have a at least a small understanding of that before we touched on it. So not many of you have spoken today, but I'm believing you did your research, so we can go forward. Yeah, to those who spoke up today, thank you. As always, it's always good to have interaction. And for those who haven't spoken yet, I don't know what you guys are scared of. I don't buy it. But yeah, we can go forward. So for today's lesson, we will be continuing from where we left off. We began to look at the idea of ordinal utility. So before we get into that, I want to do a brief recap with you guys so that we're on the same page. Seeing as we missed one day, the ideas of the things may be a bit foggy. So can someone give us a summary of what we learned in the last lesson? Just the last lesson. Whatever you remember. For me to go over everything might take a bit too long. So if we have a brief recap, that would help us move forward. I'd like to hear from the girls. Sulanji spoke. Sulanji is a name that's interesting because it can be for a guy or for a girl. But from the voice, I'm believing that was a girl who spoke. So I'd like to hear from the girls. What did we look at in the last lesson? How many girls do we have here? Priscilla, Susan, Naomi, Suilanji, I believe. Yeah, go ahead. Mm-hmm. Mm-hmm.
For example, the consumer combines the group of goods. For example, if there are different categories, let me just say things.
Mm-hmm.
There are different types of, let's say different types of groups, different types of things, and then it depends with the level of satisfaction that they give. Like you gave an example of U1.
Mm-hmm.
You gave an U1 which had something like the Bahrain C Drink 1. Those there are different types of food, but they give the same level of satisfaction. And then there'll be another type of, like you gave an example of another one of U2, which gives a more level of satisfaction as compared to U1.
Mm-hmm.
And you mentioned to say that consumers will be mostly happy to pick U2 because it carries more level of satisfaction as compared to U1.
Voila.
If I remember.
Okay. Thank you, Priscilla. That is exactly right. So, for a general part, I believe that that was most of what we looked at. The rest was a number of equations in this.
Yes. Just to add on.
Mm-hmm.
We also move on to look at the rate of marginal substitution.
Mm-hmm.
Marginal substitution of product X and Y is equal to minus the variation of product X over the variation of X. Supposed to be vice versa. So the variation of product Y over the variation of X.
Voila.
And also said to say under the zakat and difference, there you go. There are one is not good compared to the legal profession.
Voila. That's right. Who was speaking? Was that Savior?
Yes.
Okay. Thank you, Savior. Alright, what else did we look at? We gave formulas for TMS, which I said we would look at the application later. Yeah, I think that pretty much summarizes everything. If there's something I believe we need to go back to, we'll go back to lesson 4. So to those who've given a recap, thank you very much. It's helpful. So today we're going to continue on ordinal utility, specifically looking at the ordinal equilibrium of the consumer. And then in lesson 4 we also mentioned that we will still be looking at the second law of Gaussen, which is the equalization of weighted marginal utilities, and at the end of this lesson we'll see how those things come together. So today we'll be going into ordinal equilibrium. Our first slide. Here basically we'll be reminding ourselves of the factors that the consumer has to consider when making their choice when buying a good. So the first point here basically tells us that the consumer is faced with about 2 factors. The consumer wants to maximize the satisfaction, as we've seen already. They want to have the good that gives them the most satisfaction, but they have to consider the fact that these goods have specific prices and they also have a specific budget in which to use. So they have to find the good that gives them the most satisfaction but still fits within their budget. Donc, le choix du consommateur se détermine par la confrontation entre ce qu'il veut, that's to say, the maximum satisfaction. This is what the consumer wants. But then there's also what they can, ce qu'il peut, that is to say, what they can give out to receive this. Speaking of the nominal revenu nominal limité, which is the money that they are able to spend on this. And then this is also in conjunction with the general level of the prices of goods. So to summarize again, we're considering what the consumer wants, the budget that they have, and the prices of the goods that they intend to buy. So La fonction objective du consommateur est alors maximiser sa satisfaction compte tenu de sa contrainte de richesse ou de son pouvoir d'achat. So now we're coming to consider the idea of le pouvoir d'achat. This is something that you will come to when you consider the budget that you have and the price of goods. So before I continue there, are we together thus far?
I'm kindly asking if you can go back to the first slide and start again because I'm having network problems. I didn't hear anything.
Don't worry, we're still on the first slide. We're looking at something, we've already considered this, of course. Le choix du consommateur. That's to say, when a consumer is deciding to buy goods, there's some factors they have to consider. And these factors are, one, to begin with, their own budget. How much am I willing to spend on these goods? And two, what is the price of these goods that I intend to buy? So the thing is that they have a limited revenue, they have a limited budget, they can only spend up until a certain point, and then there's the price of goods to consider. Now, still on the first slide, on the second point, we are looking at the idea of le pouvoir d'achat. The power, the buying power, is something that is defined or determined by those two factors, being the limited revenue and the price of goods. Are we together?
Yes.
Okay. So, when you consider your nominal revenue and the price of goods, you come up with le pouvoir d'achat, which is also called revenue real. If you were to make an equation out of this, you would say the real revenue is equal to the nominal revenue over the price of goods. That's to say, you can only understand how much you can spend or how much you are willing to spend, how much you are able to spend when you consider the price of goods in ratio with the amount of money you have. Take, for example, you have 500 dirham to spend, okay? And you want to buy a TV. Now, the range of the prices of TVs can be between 250 and 500 itself. So that range is what defines your buying power. It means that if you decide to buy a TV for 250, it's possible that you can buy 2 TVs. But if you decide to buy a TV for 500, then you can only buy one. That's your buying power. Is that example clear? Okay, thank you. So, yeah, that's the general idea behind the buying power. So, what we'll look at now is la contrainte budgétaire, the budgetary constraint. The same thing we mentioned here, which is also called la contrainte de richesse. It's the same thing. Basically, the amount of money that you are willing to spend. So what we'll look at here are two different formulas that are equal. The first point reads, supposons qu'un consommateur affecte la totalité de son revenu nominal R à l'achat de biens X et Y qui ont respectivement pour prix Px et Py. L'équation de la contrainte budgétaire et celle de la droite de budget s'écrivent comme suit. So you see these two formulas here. The first formula that you have here is called the formula of budgetary constraint. L'équation de la contrainte budgétaire. So we've seen this one already in our previous lessons and in the exercise that I gave you. This is the formula that allowed you to see if you made the right choice. This was under marginal utility. It's a case where you considered your marginal utility and you found particular quantities that were consumed of X and Y, and when you replace them in this formula, you were able to see if it gave you the correct revenue. Do we all remember that?
Yes.
All right,
Yes.
thank you. So this formula is what is called the formula or the equation of budgetary constraint. Now, this next formula here, putting it in yellow, is what we call l'équation de la droit du budget. So these two formulas are equal, except this second formula allows you to show budgetary constraint within a graph. Like, it just helps you to show it in a graph in the same way that those groups within U1, U2, those groups of combinations of X and Y, they allow you to show that on a graph in le courbe d'indifférence. This particular formula allows you to show a line that represents the equation of budgetary constraint. Are we together?
Yes, but on the second formula is that delta x, px over py, and then that other delta.
Yes, it is. It's the negative of px over py multiplied by x. Is that okay?
Yes.
Okay, thank you. So the next phrase, cette deuxième équation, that's to say the equation of the budget line, la droit du budget. Cette deuxième équation se représente par une droite dont la pente est égale à l'opposé du rapport de prix des biens. So this line is a line that will touch one of our curves of indifference. We'll see that in the next slide. I made sure to show how it looks. In our previous class, someone asked about this particular line actually, and so I made sure to differentiate it from the others. So see it. So this particular line only has two sets of coordinates. In one case, x will be equal to 0, and then y will be equal to your nominal revenue over the price of y. And then in another case, your y will be equal to 0, and then x will be equal to r, that's nominal revenue, over the price of x. Those are the two things we have down here. Before I go to the graph, is that point clear? Any clarification needed?
Maybe you can just repeat on the last point on x is equal to 0 and y.
Okay. This is something you'll see as we go into the application, but this line, the budget line, only has two sets of coordinates. Of course, you know this from mathematics. When you're drawing a graph, you always need coordinates for x and for y. So sometimes there are those coordinates where x will be equal to 0, then y is equal to something else, and then y is equal to 0, and then x is equal to something else, where it gives you some sort of straight line. So this is one of those kinds of graphs or lines. In a case where x is equal to 0, y will be equal to the formula r over py. If you come back to the first equation here, showing us, rather the second equation, showing us the budget line, you see that at the end here we have r over the price of y. So this is the case. In a case where x here is equal to 0, your y will be equal to this last part here. But then, in a case where y itself is equal to 0, it will now be r over the price of x. Is that okay?
Yes.
Yes.
Okay, thank you. So like I mentioned, we'll have a session where we're doing this application, and you'll be able to understand it better when we come to that point. So I'll just shift over to a different part. I couldn't do this on the slide, but in a PDF it's more possible. So this is a graph we looked at in a previous lesson. The line I want to show you is this one here, that's now in red. This is what you call your budget line, la droite du budget. So you see it only has two coordinates in the case where x is equal to 0, y is equal to r over the price of y, and in the case where y is equal to 0, x is equal to r over the price of x, and that's how you come up with this line here. Is that okay? Can everyone see this clearly?
Kindly explain that maybe.
Alright, no problem. So this line that you're seeing here is a visual representation of the equation for revenue, the equation for la contrainte budgétaire, and it itself is called the budget line, la droite du budget. So this line helps us to see exactly what the budgetary constraint looks like in the graph. So this line here that's in red is the budget line. The budget line only has two coordinates. In one case, x will be equal to 0 and y will be equal to r, that is the nominal revenue, over py, the price of y. And in the other case, y will be equal to 0, while x is equal to r, which is your nominal revenue, over px, which is the price of x. That's all you need to know for now. We'll look at it more in the application. Is that okay?
Yes.
Alright, thank you. Alex, how much time do I have?
Right. 6 minutes.
6 minutes. Alright. So this lesson, we won't take too long. I expected us to take more time on the discussing the research points, but that ended up pretty quickly. So we won't take too much time today. We'll be done soon. The next lesson we'll look in. The last thing we'll do is the application, and then we'll go into our last topic for these lessons. So in the last 6 minutes, we will just have a brief overview of this. So once again, we're still under ordinal utility, and we're looking at a couple of things. Today, we're looking at what is called the ordinal equilibrium. And under the ordinal equilibrium, we've looked at 1. La contrainte budgétaire, la contrainte de richesse du consommateur. And then now we're going to look at the optimal combination, which we've seen already, but we're looking at it under the heading of ordinal utility. So our first phrase, la combinaison optimale de biens X et Y qui maximise la satisfaction du consommateur et détermine son équilibre unique est celle qui correspond au point de tangence, the meeting point, de la droite du budget avec la courbe d'indifférence la plus élevée possible. So, to come back in English, we've already seen what the optimal combination of goods is. It's the one when you replace it in that formula for revenue, it gives you your exact revenue, and this is the combination that gives our consumer the most satisfaction. We saw in marginal utility that at this point UMX is at 0 and UX, that is a total utility, is at its maximum point. So now in terms of ordinal utility, we are looking at it in terms of the graph we just saw. When you show the point of equilibrium, the optimal combination on your graph, it's a meeting point between the line we just saw, which is the budget line, and a particular curve of indifference. So let me just go there and I'll explain that again. Do confirm that you can see. Are you able to see this graph?
Yes.
Okay. Thank
Yes.
you. So what we have here is the point E. Point E is the point of tangents, the meeting point between our budget line and an elevated, one of the most elevated curves of indifference. So I mean, naturally you would think that, okay, the goods that would give us the most satisfaction in this case would be in the group of U3. Yes, that's true. But then when we bring into consideration your budget, you now come back to the idea of buying power. In this case, you might find that within U2, you have a combination of goods that costs about 700, and then the money you have also is 700. But when you go to U3, it gives you the same satisfaction, yes, but the goods within this one cost 800. Now 800 is outside of your buying power. It means that you can't pick goods within that group. Does that make sense? All right.
Yes.
Okay. Thank you. So now, this point of equilibrium, this meeting point, is the point where you have a combination of goods that gives you the most satisfaction, that fits within the buying power you have, that fits within the budget that you have. So whenever you are asked to draw up this graph and you find this point where this line touches one of your curves of indifference, this is your point of equilibrium. This is the point that gives your consumer the maximum satisfaction. That means that at this point you have two goods to consider also, because it's a combination. You have the goods X and Y. The person who drew this graph was careful to show that it's XE and YE, just for you to see that it's linked to that point there. Voila. So this is the best combination of goods that you can have, and it fits within your budget. And that's pretty much all there is to it.
Yes, I have a question under the same question.
Mm-hmm.
So, like you guys, how did you manage to come up with these games? Like, which points were you using to draw these games?
This particular graph.
Yes, for the what indifference games.
Yeah, so this one, it doesn't have any particular points because it's just meant to show you what it's supposed to look like. There aren't any specific numbers. They didn't really do any calculations. It's just supposed to give you an idea of what it should look like. When we do the application, you will do this yourselves and you'll be able to see. This one doesn't have any specific numbers or anything. It's just to give you an idea of what it's supposed to look like. Is that okay?
Yes.
All right. Okay, so let me just go back to our slide. Voila. In our second phrase, dans notre exemple, la combinaison optimale correspond au point I, E, X, E et Y, E, de la tangente entre la droite du bouger et la courbe U2. À ce point d'équilibre, le taux marginal de substitution est égal au rapport de prix des biens. So at the point we just saw, when hold on just a second, sorry, just a moment. Alex, how much time do I have?
Just seconds now.
Just seconds. All right, so at this point, the marginal rate of substitution, the TMS, is equal to the ratio of your price of goods and the derivative of X and Y. We'll see this more. I think we can go on our break now. When we come back, we'll finish. Perhaps we'll see an application, or we'll see. But yeah, we can go on our break. We can go on our break now. Alex, you tell me to come back.
at 45, now it's 50.
Okay, thank you, Alex. Alright, so there's a question from Xavier in the chat. It says, for example, I want to buy a combination of different sweets, that's U1, a combination of different biscuits, that's U2, and a combination of different drinks as my U3, and a revenue of 50. Is it possible to draw la carte en différence? No. If you take it generally, it may be possible, yes, but the main idea, I believe, behind la carte en différence is you have combinations of the same types of goods. So like in the example that I gave previously, you had some types of medicines and some types of drinks. So each one had different types of medicines and different types of drinks, but the idea was that it was combinations of drinks and medicines. So I don't believe that's possible. Yeah, in this manner you've put it. Perhaps if it was in U1 you have biscuits and drinks, U2 biscuits and drinks, U3 biscuits and drinks, or biscuits and sweets, or drinks and sweets, anything of that nature, but like basically the same types of goods, just offering you different levels of satisfaction. Does that make sense? Okay, good.
Yes, it does. Thank you.
Okay. So we'll come back to the idea of the optimal combination. What's this here? Okay. So, I've already shown you that point there. The last thing let's consider is the idea of the marginal rate of substitution. In our previous lesson, we said that this rate of substitution is what you consider, for example, if you want to have more of X and less of Y, but still have the same satisfaction. So this formula we have here just shows us how we will come to find this rate under the idea of ordinal utility. So it's equal to the derivative of y over the derivative of x, which should also be equal to price of x over price of y. Yeah, and we'll see that what that means as we go on. The last slide we have here is the last thing we'll look at, which is the principle of equalization of weighted marginal utilities. So I mentioned in the other lesson that we're still working with the idea of the second law of Gaussian, the equalization of weighted marginal utilities. So our slide here tells us that at the point of equilibrium, the weighted marginal utilities of goods are equal. Au point d'équilibre, les utilités marginales pondérées de biens sont égales. C'est-à-dire, when you have umx over umy, it's equal to price of x over price of y, or you can say umx over price of x is equal to umy over price of y. It's just a formula for you to keep in mind. Is that okay?
Yes.
Alright. So it tells us also that within this formula, price of x, well, on this last part here, price of x over price of y, px over py, is what we call le taux d'échange du marché. And then umx over umy is what is called le taux d'échange subjectif, which is the same as TMS. So the difference between these two is that px over py is kind of the standard for the market. It's the standard for the consumers. It's the same standard for the producers. That is le taux d'échange du marché. But then UMX over UMY est le taux de change subjectif. So this is something that's for the consumer specifically. This is something that the consumer chooses. In the same way we explained in the previous lesson, the consumer can choose to have more of X and less of Y, but have the same satisfaction. So it's something that you choose on your own. It's not something that's set by the market. Is that point clear?
Just run over it.
One more time.
Last time.
Sure, no problem. So just take note of how it's written here. Px over Py est le taux de change du marché. So this is the standard for the market. This rate of exchange, it's the same for the consumers, it's the same for the producers. It's something that you can't change. I mentioned in one of the lessons that as we consider these things, the prices of good is fixed. It means that if they tell you that the price of X is 2 and the price of Y is 4, it's always like that. You can't change it. So it's a standard rate, le taux de change du marché. And then when you come to UMX over UMY, le taux de change subjectif, it's something that is unique to the consumer. It's something that the consumer makes for themselves. It's something that you choose to do on your own. The same example of getting more of X, less of Y. It's your choice. You can get more of Y, less of X. However, whatever pleases you for you to get your maximum satisfaction. So the reason that it's called taux de change subjectif, it's because it's for the consumer specifically. The consumer can change it however they want. But le taux de change du marché is something that you can't change. It's standard for the consumer and for the producer. Est-ce que c'est compris?
Oui.
D'accord, très bien. Donc, à ce point, on a fini notre cours. We've pretty much looked at everything I intended for us to look at today. I just wanted us to finish up on the idea of ordinal utility. I'd like to go. There's a question from Xavier.
Yeah, so is there any difference between marginal utility and weighted marginal utility?
Let's say the concept is different. You use marginal utility to find weighted marginal utility. When I was trying to explain this concept, I believe we mentioned that we assume that the consumer knows the marginal utility of goods, and so they have all of these and they are comparing them. That's why you say it's weighted, pondéré, it's compared. Voila. So you have a number of marginal utilities before you, and you just pick the one that's the most suitable for you. Yeah, so it's just a difference in notions. You use your marginal utilities to find the weighted marginal utility. Is that okay?
Yes, thank you.
Voila. Okay, so I'm trying to analyze if it's possible for us to look at the application a little bit. We still have quite a bit of time, so I think we can look at this one just briefly, and then we'll come look at it more in the next lesson. Is that fine? Unless you guys want to stop, I'm fine with it, but it would be, I think, a bit better for progress if we just look at this one. Then the next lesson we look at the other application B, and then we'll be done with this. So yeah, you tell me what you want. Do you want to break early for a Friday, or we finish up this last part?
I can finish up the last part.
Well
You can
done.
finish up, madam.
Okay. Who was the first to speak?
Me, yeah.
Okay, sure. Alright, so we'll finish up. So what we have here is a question. The best way to look at an application is to look at the question, of course. So I'll read it. Soit un consommateur dont les choix sont exprimés par sa fonction d'utilité, U est égal à F x, Y est égal à X fois Y, et qui veut dépenser rationnellement son revenu R est égal à 2040 dans la charte de biens X et Y, dont les prix sont respectivement Px est égal à 2 et Py est égal à 4. Quelle est la combinaison de biens X et Y permettant à ce consommateur de maximiser sa satisfaction? So, the question, first of all, gives us the function of utility, of total utility. In this case, total utility of X and Y. That's what we have here. To find the total utility of X and Y in this question, it's equal to X times Y, the total quantity consumed of X multiplied by the quantity consumed of Y will give you your total utility. You'll find that in different questions, they might give you different formulas for total utility. So this is one thing you should always take note of. For example, when you're solving a question like this, the first thing you should write down is the formula or the function of total utility. That's the first one here. So our consumer, in this case, wants to rationally use his revenue, which is 240. In this case, we can say kwacha or dirham, it's not specified. And then this consumer wants to buy two specific goods. These goods have different prices. X is equal to 2 and Y is equal to 4. The price of X, the price of Y is 2 and 4. So our task now is to find the correct combination of goods that allows our consumer to maximize their satisfaction, that allows them to have the maximum satisfaction while they're still staying within their budget. So there are two formulas we can use. The first one is the formula of the taux marginal de substitution, and the second one is le multiplicateur de Lagrange. So in this session we'll focus on this first one. Okay, so before I continue, we're together so far?
Yes. Oui.
Okay, thank you.
No.
No? Where should I repeat?
I was having some network issues. Don't know if you can start again on the application.
Sure, no problem. So basically, I was just explaining the question we have before us. So the first thing we see is that we're given a particular function for total utility. I mentioned that in different questions you face concerning this, they might give you different functions for total utility. So the first thing you do when solving this question is take note of what the function of total utility is. In this case, it's X times Y, the quantity consumed of X multiplied by the quantity consumed of Y. You'll use this at the end. The next thing we see is that our consumer wants to rationally utilize or spend their revenue, which is 240, in buying two goods. These two goods, as usual, have different prices. For X it's 2 and for Y it's 4. So our task is to find the correct combination of goods that allows our consumer to get the most satisfaction while still remaining within their budget. I hope that's okay.
Oh wait.
Mhm.
So that's Px is equals to 2 and not Px is negative 2.
Yeah, it's equal to 2.
Okay.
Hold on.
So wait, even in this formula, is there any equal sign? Oh, okay.
It's clearer now?
Yes.
Okay. Is it clear for everyone?
Yes, it is, but I'm just worried about the F as in
Oui.
the function.
Voila, it's a function. That's to say that total utility is equal to the function of X and Y, which is ultimately equal to X times Y. It's okay?
Yes,
Okay. Alright, so before I go on, is this part clear for everyone? We can go forward.
Yes.
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 Okay, thank you very much. Alright, so now the TMS method. We'll go back to the formula that we saw previously. that says that at the point of equilibrium of the consumer, the one we saw there as E, the TMS, le taux marginal de substitution, est égal au rapport de prix des biens. That's to say that the derivative of y over the derivative of x is equal to umx over umy is equal to price of x over price of y. So in this case, we're going to come back to our formula. Remember, I told you that the first thing you should do is write down the formula for total utility, which is the one we have here. What we're going to do is we're going to differentiate to find the value of marginal utility of x and of y. It will give us these two formulas we have here. So just take note of this. We have the marginal utility of x is equal to u prime of x is equal to y. That means when you derive this formula, how do I put this? The derivative of this formula in terms of x is equal to y, and the derivative of this formula in terms of y is equal to x, which we have here. Any clarification needed there?
Yes, explain that one again.
Okay. So just take note of this. Since our formula for u here is the function of x and y, when you derive in terms of x here, how do I explain derivatives properly? It's been some time in mathematics. When we go deeper into the application, in fact, when I give you work, this is when you'll be able to see this properly. But when you derive this formula here, you'll find that in terms of x will be equal to 1. So basically it's y times 1. That's why here you have u prime of x is equal to y. And then when you derive in terms of y, you find that y itself is equal to 1. So 1 times x is just x, and that's why you have u prime of y is equal to x. Yeah, basically you've derived to get these two. When you derive in terms of x is equal to 1, 1 multiplied by y is y. When you derive in terms of y is equal to 1, 1 times x is equal to x, and that's how you have these two formulas here. You won't see this much in TMS. You'll see it more in terms of Lagrange, because in this case all you have to do is just get the price of x and price of y and come up with a ratio, the same way we did in terms of marginal utility when we're looking at it, which is the second line we'll see here. Does that make sense to some degree?
Yes.
Could you repeat that? You became kind of low towards the end. It symbolizes let's say it symbolizes marginal utility, because here it says um of x is equal to u prime of x. U prime of x just tells you that you are deriving this formula here in terms of x. So that means when you want to find your umx, you derive the formula. So in terms of x, it's y. So to simplify what I've said, u prime of x just represents umx. For you to find your marginal utility in this case, you differentiate this formula. It's clear? Alright. Thank you. Is that point clear for everyone, or should I try to explain a bit more? here. As always, I mentioned that you can, if some point is not so clear, you can always ask your friends, see who understands it a bit better, and if amongst yourselves you can't find anything, then you can come to my DM and I'll try to explain the best I can. Right, so our next point shows us the numbering behind this. I mentioned just now that mostly what you have to do is just get the prices of X and Y. So we come down here, it says puisque Px is equal to 2 and Py is equal to 4, therefore umx over umy should be equal to y over x, should be equal to price of x over price of y. We saw in our question, hold on, here, the price of x is 2 and the price of y is 4. So you'll get those and replace them here. In px and py, you have 2 over 4, and then the next thing you have is 1 over 2 when you simplify it, which will in turn give you x is equal to 2y. Let's try to bring that down a little bit. Voila. So let's see here. What we'll do is we'll get all of this here, copy, and where is it, and put it here. Do confirm that you can see. Let me just make this bigger.
Yes.
There we go. So we saw that the price of x was 2 and the price of x was 4. And then we simplified it to have 1 over 2. What we'll do is we'll get this part here. Copy. And then voila, I see. We'll have it here. And then the next thing you have is seller. Copy and paste. So it brings us to a case where when you compare this ratio you made here to y and x, you have y is equal to 1 and x is equal to 2. So what you do is that you will cross multiply for you to make another formula, which is what we have here. I'll just copy this and paste it here. Voila. That means that x is equal to 2y. X times 1 is 1, 2 times y is 2. Does that part make sense?
Yes.
Okay, cool. So you see that TMS is pretty easy. What you have to do is just compare the price of x over price of y, and then make a formula in terms of the quantity consumed of y and the quantity consumed of x. What you would do after that point is that you're going to get this formula here and replace it in your formula for revenue. Hold on just a second here. So you're going to get your OG formula for revenue and try to put that in there. So let's see here. Let me go and find the original one so we can see exactly how we came to this point. Where are you? Not here. replacing 4. Alex, how much time do I have?
It's actually time up. I was just waiting for you to finish.
Okay. So let me just find the formula for budget, and then yeah, we can go on break for now, and then we'll just come back and finish off. So before we go on break, let me just find the formula. Here it is. We're going to copy this. We're going to have it here. Okay, before we go on break, would you prefer that we just finish now? Because this will be the last point anyway. Or we go on break and come back?
Let's just finish.
Okay, good.
We can just finish. Let's just finish.
Alright, cool. Good then. So, now that you found this formula here, you're going to replace it in this case. So we're going to go back to the top and get some values. For R, we have 240. So what we'll do here is we'll have 240 is equal to X times the price of X plus Y times the price of Y. So we already know the price of X. The price of X is 2. Voila. So we'll have the price of X being 2, but we don't know what the value of X is. For now, we just know that X is equal to 2Y. So we'll get that value we found and put it here. 2Y. Then plus the price of Y was 4. So we'll come back here, put in 4. And then Y is just Y. If X is equal to 2Y, then Y is just Y. Am I getting this correctly? R is equal to 240 by 2X plus 4Y. Voila. Hold on a second here. Let me do some confirmation. 2x plus 4y is equal to 2 by 2y plus 4y. Voila. So if x is 2y, then y is just y. So we just have y here. When you go further, you have 240 is equal to 4y plus 4y. Next, you have 240 is equal to 8y. And having found this point, you'll be able to find what your exact value for y is, and therefore find your exact value for x. So can someone divide 8 into 240? What is the value of 240 divided by 8? Which will give us our answer for y. What is 240 divided by 8?
30.
30. Shukran Zev. Voila. So now we have our value for y, which means we can also find our value for x. If x is equal to 2y, then x will therefore be equal to 60, because we'll have here 2 multiplied by 30, voila, 60. Are we together so far?
Yes.
Come again? You were a bit low. The first part, when we were replacing values here. Okay. Alright. So what we did basically was just that we got this that we found here and replaced it into, our formula. Where you have x, you put in 2y. From our question, we see that r is equal to 240. So we put 240 here. And since x is equal to 2y, we replace 2y here. This 2, the first 2 we have here, is the price of x. So it's the price of x multiplied by x. In this case, x is 2y. Next, we have the price of y, which is 4, multiplied by y. Now, if x is equal to 2y, then y is just y. Does that part make sense? Okay. Yeah, and then after you do your calculations, you come up with 240 is equal to 8y. This last formula here is what helps us to find the exact values of x, the quantity consumed of x, and the quantity consumed of y. And so now, just for confirmation's sake, we'll see exactly if it gives us the exact value we're looking for. Don't circle. If we say, let's start with x, right? X is 60. If we say 60 multiplied by 2 plus 30 multiplied by 4, will that give us 240? Someone do the calculation. What value does it give you?
240.
Voila. So yeah, that is the TMS method for you. It's generally easy. All you have to do is make the comparison between the price of x and the price of y, make your ratio 1/2, and then just find the values of x and y. So I'll send this into the group and you'll be able to go over it for yourselves. I'll see if I can send work for this particular question along the weekend just for you to practice and get used to it. And then yeah, TMS is the easiest. Lagrange is a little bit trickier in that case, but yeah, even that one you'll be able to get. So I want to see if there's one last thing that we should do before we close. Let's see. Right, so there's one more thing we have to do. We have to find our total utility, which was here. So I'll copy this and reduce this a bit to 20. So the next thing, or let me just move this side and make a new text box. You see, we're going to paste this here. So for us to find our total utility, let's just break this down a bit more. U is equal to x multiplied by y. So we've already found our values for x and y. X is 60 multiplied by y, which is 30. Voila. So one more time, someone just do this calculation. What is 60 times 30? It should give you about 1,800 if I'm not mistaken.
Yes.
1,800?
Yes, it is.
Voila, thank you. So yeah, that's the last thing you have to do. You found your values for x and y, then you find your value for the total utility, which is 1800 in this case, and you're done. In Lagrange, we'll see that we'll handle the same question in a different way, but we'll still have these same values. Mostly in examinations, you'll be questioned on Lagrange. They probably won't ask you TMS because it's very easy. But yeah, if the more you understand one, the more you understand the other. So I believe for today we're done. Before I close up, any questions, any clarifications that you need? In this case, you may not see it so clearly. Yeah, I mentioned previously when I was explaining this that you will see this more when it comes to Lagrange differentiation of sorts. In this case, for you, just see it as a formula. Or let's see if we can apply it now. If the derivative of x is equal to y, and that is your marginal utility, then it may be the values that we found already. I believe that makes sense, because if you have umx over umy, it will still give you 1/2. So let's try to apply this as a last thing. Yeah, so let's just get these values here, copy and coller. Voila. So if our marginal utility for x is equal to the derivative of this formula, which is u prime de x, is equal to y, it means that our umx is equal to 30 from this point here. And then if our umy is equal to where's my prime de y, which is also equal to x, then our umy is equal to 60. Voila. So what we'll do is we'll see if this equation here is true. So let's just move this over here a little bit, break that, and have and have us a new text box. Voila. So what we'll do is we'll get this here, copy, and coller, break that down to 24, move this here, and then it should be equal to the price of x over the price of y. That's what we have, and just copy this, copy, coller. And in this case, price of x we saw was equal to 1/2 when we broke it down. You just copy, voila, coller. So what we have to see is now is our umx over umy equal to 1/2. I think if you can take the values for yourselves even now, it's easy to see that it actually is true. So what we'll do is we'll just get this and replace the values. For our umx we have 30, and for our umy we have 60. And so, quick question, if you break this down, will it in fact give you 1 over 2?
Yes.
Voila. So yeah, that's basically how you get to apply that part. It's more like a secondary thought than anything. It's just, again, it's kind of also more like proof that you did the right thing. In your regular calculations, which are these ones here, you probably won't see it. It doesn't, because you can't find it until you find the values of x and y. So you won't, for you to find the values of x and y, you won't really need it, but you can use it to prove that you did the right thing. I hope that's clear. There's a question, but you're low. No, there was someone else speaking. I believe I heard a lady's voice. No? Okay. Voila. So, if that's clear for everyone, then I believe that marks the end of our lesson for today. Next lesson should be next week. We'll look at the Lagrange method, and then we'll proceed to the last section for courses. I believe by next week we should be done.
I have a question.
Go ahead. Go ahead. Who was speaking?
I have a question.
Yeah, Alex, go ahead.
Yes, on that total utility which we found, 1,800,
Voila.
doesn't it have some units of some thoughts? Kairiko school or Umpeza massive, paragraph.
You need to always put in the units.
Can you get me?
Voila, yeah, I can get you. Your total utility does not
Yeah,
have
does it
units.
have units?
No, it doesn't. It's just the way it is there. As long as you indicate that it's what you have found is in fact your total utility, then you're fine. But it doesn't have particular units. Let's see, how does the TMS show in this guy? Just give me a second. Let me check through my notes. There is to a degree how it's expressed, but it's not so explicit. Just give me a second to clarify there. Where is my Kaplan difference? Okay, so let me come back to these calculations here. So in the TMS method, in the same as the Lagrangian method, you are trying to find the exact quantity of x and y that gives you the most satisfaction, but is within your budget. So this is the point where you've looked at the quantities, yes, but now you're also comparing them to the amount of money you have. So the quantities you find here, they correspond to the combinaison optimal. They correspond to this point here, E. So that's how TMS plays out in Lacan difference. You use it to find the exact combination of x and y that gives you the most satisfaction and stays within your budget. So in this case, for example, we can say that xe will be equal to what's the value for x, will be equal to 30. Okay, so we say that xe here is equal to 30. Well, I hope I haven't switched these values. Have I switched these values? Voila, 60, sorry. You find that xe is equal to 60. Let's put our 6 here. And you find that your ye is equal to 30. So the only way you see it, it's just that the TMS helps you find point E. In my personal notes for school, I tried to clarify that. Let me just see if I can write that here. E is equal to TMS of x and y, which is equal to price of x, which is the one we have down there, your 60 and your 30, over the price of y. So yeah, that's how it's shown in la carte d'un différence. I hope it's clear. Yeah, you're still a bit low. Uh-huh. It's called the point of equilibrium. Yeah, it's called the point of equilibrium. Le point d'équilibre. Let's come back here. La point d'équilibre, it's also called the optimal combination, but yeah, it's called la point d'équilibre, the point of equilibrium. You can also call it the point de tangence, the meeting point, but yeah, I think the main name is this one, point d'équilibre. Yeah, I hope it's okay. Any more questions? Okay, I will have to take that as a no then. Alright, so that means that we are done for today. Thank you for your attendance. Stop sharing my screen. It's always good to have you guys. Thank you for always being cooperative and attentive and responsive. I appreciate it. It makes my work a lot easier. So I'll see if I'll send at least one question along the weekend for you to practice TMS, and of course I'll send the work, I'll send the video so you can revise, go through, and all of that. Otherwise, thank you for attending, and class is dismissed. Have a good weekend. Bon weekend à vous. Shukran.
Bon weekend, madam.
Shukran. Shukran. Okay.